Hello everyone. In today's video, I'll be explaining how an overvoltage protection circuit works using a simple op-amp and MOSFET configuration. This type of circuit is crucial in protecting sensitive electronics from high voltages that could damage them. So let's dive right into the circuit and see how it operates. Here we have the circuit set up in simulation software. The main components are a 741 op-amp which acts as a comparator, which we are using as a comparator, a 2N7000 N-channel MOSFET which acts as a switch, an LED with a current limiting resistor to visually indicate an overvoltage condition, a couple of resistors to set the reference voltage. Let's go through each part of the circuit step by step. First, we have our input voltage source represented by V1, which is set to 2.5 volt. This input voltage is what we are monitoring. If this voltage rises above a certain threshold, the circuit will respond by turning on the LED. To establish this threshold, we use a voltage divider made up of R1 and R2, both with values of 10 kilo ohm. This creates a reference voltage at the non-inverting input of the operational amplifier, which is set to approximately half of the supply voltage or 2.5 volt. This reference voltage serves as our trigger point. The 741 op-amp is configured as a comparator. This means it compares the input voltage to the reference voltage. When the input voltage on the inverting input exceeds the reference voltage, the op-amp output will go low. If the input voltage is below the reference voltage, the output will stay high. This is the critical behavior that makes the op-amp function as a switch in this circuit. Now let's move to the MOSFET 2N7000 and LED section. The output of the op-amp is connected to the gate of the MOSFET through R3, a 10 kilo ohm resistor. The MOSFET acts as a switch for the LED. When the op-amp output goes high, the gate of the MOSFET is pulled high, keeping it off. This means no current flows through the LED, so the LED remains off. However, if the input voltage rises above 2.5 volt, the op-amp output switches to low. This puts the gate of the MOSFET low, turning it on. Current flows from the 5 volt supply through the LED and R4, causing the LED to light up and indicate that an overvoltage condition has occurred. So now I'll show how this circuit works. Now the input voltage that we have set is 2.5 volt. It is exactly equal to the threshold voltage, which is 2.5 volt. So let's see what happens. The LED lit up. This shows that at exactly threshold voltage, which is V input is equal to V reference, the LED will lit up and it will indicate a over voltage condition. Now let's change the input voltage. If the input voltage is below 2.5 volt, which is the reference voltage, then the LED will not lit up, which shows that the input voltage is less than the reference voltage or the over voltage. Now let's change the condition. Now the input voltage is greater than the reference voltage. Let's see. The LED lit up, showing the that this is a over voltage condition. So that's all. Thank you very much.